Hello, everyone. I am going to be presenting new studies in the Chaco region of Argentina. The Gran Chaco Forest in South America is distributed in 3 countries, in Bolivia, Paraguay, and Argentina, and is one of the largest biomes in South America with 1 million square kilometers, following the Amazon forest in size. The Chaco region is characterized for being a large flatland, semi-arid and warm, with very hot summers and absolute temperature that can reach 49 degrees Celsius in summer. For this reason, the Chaco forests are called the heat polos of South America and drive atmospheric circulation associated with the monsoon activity in summer season. The vegetation of the area is xerophytic and is adapted to the intense heat and high evapotranspiration, and is mostly dominated by hardwoods, and is one of the reasons why these forests have been traditionally underrepresented in dendrochronological studies. The Chaco region has been historically, since the 19th century, source of timber goods, mainly for railroad constructions and tannin extraction. But during the last 30 years, a heavy process of deforestation has been taking place in the Chaco region. Since the end of the 1970s and the beginning of the 1980s, more than 40 million hectares has been cleared for the expansion of agriculture in the Gran Chaco, mainly for soybean growth and raising livestock. And Argentina, sadly, has been the country with the highest rate and surface of deforestation. So here you have a comparison of the Chaco in Argentina from the 2000 to 2019 from the NASA observatory. And you can see how much of the surface has been cleared during these 20 years, almost 30,000 square kilometers. And this process of deforestation, among other factors, has been triggered by the increasing precipitation in these drier regions in the last decades. You can see here a regional precipitation series from the northern part of Argentina, which spans from the 1912 to 2018. And you can see here that from 1915, there has been a wet tendency. And there has been a marked increase in precipitation from the 1975 to the present. This wetting trend is called by some climatologists as the climatic jump of the northern part of the northern Argentina. Also, this increase in precipitation has been accompanied by an increase in the frequency of the very extreme wet events in the last decades. And you can see the very extreme wet events as the blue triangles in the series, and how concentrated they are in the last decades. So we developed 3 new tree ring chronologies from Echinopsis lorenzi, quebracho colorado, which is a very iconic species in the region. And we developed the 3 ring chronologies along a north-south gradient. The tree ring chronologies span from 100 years to 272 years, are very well replicated. The 3 ring chronologies are Laguna Yema, Palmitas, and Weisburg, from the northern part to the southern part, and share a very interesting feature among them, in which is that the 3 chronologies show changes in the growth from the 1950 to the present. And there is a notorious high interonal variance in the 3 tree ring chronologies. So we analyzed the tree ring chronology with density plots, and the data curves pre and post 1950, pre-1950 is the pink curve and post-1950 is the blue curve, indicates a differential behavior of the tree rings in the 3 chronologies. So we found a greater dispersion of the data, which is more extreme events in the last decades. And in general, there is a tendency of the three-ring chronologies present higher positive extreme values, which means that since the 1950s, there has been a shift in the deviation and the magnitude of the three-ring chronologies of the three-ring data, and that are responses of the vegetation to the higher amount of precipitation. They are following, the tree growth is following the tendency in precipitation. So additionally, we compared the three-ring chronologies with gridded precipitation data, and we found that the northern chronologies from Laguna Yema and Palmitas show responses to a rainfall that is coming from the monsoon core region, which is the tropical Atlantic, the southern Amazon, and the eastern flank of the Andes. While the Weisburg chronology, which was located in the southeastern part of the region, shows precipitation influence mainly from the South American Convergence Zone region, which is the subtropical Atlantic. So to conclude, we present here three new three-ring chronologies from Echinopsis lorensis from this very dry tropical forest that span from 100 years to almost 300 years, 272 years. These species show an increment in the variability of annual growth from the 1950 to the present, which seems to be responding to the precipitation variation in this of the regions in the last decades. And lastly, these chronologies are registering main sources of humidity that are characteristic of the South American summer monsoon. And then it opens the possibility for analyzing the long-term variation in precipitation, both in the chronologies as in the instrumental record. So thank you very much for your attention.